Simple PHP Engine is a PHP 8.5 tutorial, one small web app, built 9 times. Each chapter adds exactly one idea, as a strict diff of the one before it. No framework, no dependencies, plain modern PHP that people and AI agents can read. From Chapter 3, every request is 4 validated parameters: object, method, id, and export. It runs on PHP's built-in server, with SQLite from Chapter 7. Nothing to install but PHP. 9 chapters, 2 minutes each. Let's start. This is a complete PHP web page. 3 pages, working navigation, and a real not found response. And the whole thing is produced by a single PHP statement, with no framework and no configuration behind it. The entire program is this: echo, then a new anonymous class. PHP builds the object and prints it, and printing an object is what triggers its toString method. The pages live in one typed constant, each name mapped to a title in its HTML. Because it's a constant, it's fixed when the file is parsed and shared across every request. These 2 properties use asymmetric visibility, which arrived in PHP 8.4. Anyone can read them, but only the class itself can set them. No getter boilerplate. Here's the PHP 8.5 pipe operator handling the request. Read it top to bottom, take the query parameter, trim it, lowercase it, and fall back to home when nothing is left. So a messy input like this, spaced and uppercased, still resolves cleanly to the About page. Ask for a page that doesn't exist, and the code returns a genuine 404, not a 200 that merely says not found. That status line is what browsers, search crawlers, and the test suite all rely on. Rendering is another pipe. The page names become links, and the current one is marked active. The whole document is a heradoc, HTML, written plainly as HTML, with no concatenation and no templating engine. One habit from the very first chapter: the input is only ever used to look a page up, never printed back into the document. So even a deliberate script injection attempt simply becomes an unknown page and returns a clean 404. That is the entire engine in 57 lines. Next, Chapter 2 gives the very same page a proper look: shared styling, dark mode, and an app shell. Chapter 2 takes the exact 3 pages from Chapter 1 and dresses them in a complete application shell. A bar across the top, a navigation panel on the left, and a settings panel on the right, and every pixel of that comes from shared CSS, not from the PHP. The settings panel restyles the whole page on the fly. This is the ocean scheme. And this is forest. 4 schemes in all, each of them just a single class set on the root element. It also flips between light and dark, and your choice is remembered in local storage for the next visit. Back to light, and notice the layout never moved through any of that, only the colors changed. The remarkable part is the PHP, because it barely changed. This is still a single echo of a single anonymous class, exactly as before. The page's constant now pairs each page with an icon name, ready to become links in the navigation sidebar. A second constant lists the 4 color schemes, again just an icon and a label for each one. The request selects a page exactly as it did before, and a match expression returns that page's content, or a clean 404 for anything unknown. The navigation links are built with the pipe operator, mapping every page to an anchor and marking the current one as active. And the entire shell, the top bar, both panels, and the main area, is one heradoc of plain HTML with no templating engine in sight. It pulls in 3 shared files: the base styles, the site theme, and the script that runs the sidebars and themes, and every later chapter reuses exactly these. The About page makes the lesson concrete. Moving between pages swaps only the content, while the shell around it stays put. Contact is a plain mail-to link with no JavaScript at all. A form the server genuinely receives waits until Chapter 6. And small flourishes, like this toast notification, are a single shared JavaScript call. That is Chapter 2, the very same engine, now presentable. Next, Chapter 3 introduces plugins, and the code finally begins to grow. Chapter 3 keeps the exact same look as before, but tears out the single class and replaces it with a real plugin architecture. This is the whole idea in 3 lines. The request names a class and a method, and the code builds that plugin and calls that method. Before any of that runs, a context object validates the 3 request parameters, which plugin, which method, which format, against strict allow lists. One small helper does the checking, read the parameter, test it against a pattern, and fall back to a safe default when it is missing or malformed. Every plugin extends this abstract base, which defines the 5 basic actions: create, read, update, delete, and list, each defaulting to a friendly, not implemented stub. A concrete plugin overrides only what it needs. Home implements just list, marked with the override attribute so a typo can never silently create a new method. Ask a plugin for a method it has not implemented, and the inherited stub answers honestly instead of crashing. Ask for a plugin that does not exist, and the dispatcher returns a genuine 404 rather than a broken page. The same request can answer in 2 formats. Ask for JSON, and the very same data comes back as JSON instead of an HTML document. So every page in the application is also an API endpoint, for free, with no extra code to write. The contact plugin shows a plugin reading shared state, the site's email address, straight from that one context object. And there it is on the page, a working mail-to-link, built from that single shared value. The entire program is still one expression. Build the context, hand it to init, and let it dispatch and render. That is Chapter 3, the same 3 pages, now each a self-contained plugin. Next, Chapter 4 splits every plugin cleanly into a model and a view. Chapter 4 looks identical once more, but inside, every plugin has split cleanly into 2 halves, a model and a view. The model's job shrank to one thing: return data. Each action now hands back a plain array, a title, and a body with no HTML at all. The view's job is the other half. Turn that data array into HTML. A base view supplies a generic card, so simple pages need no view of their own. Init now assembles both halves. It asks the model for data, finds the matching view, and merges the rendered HTML into the output. This single line is the fallback. If a plugin has no view of its own, it quietly uses the base view, so a view is always optional. The About page proves it. It has a model, but no view, so the base view renders it, and to the eye, nothing has changed. Here is the most important habit in the whole series. One escaping helper. Run over every value before it ever reaches the page. Watch it work. The home body deliberately contains bold tags written as text, and because output is escaped, they show as characters, not markup. There they are on the page. The angle brackets shown literally, never interpreted. That is a whole class of injection attacks closed off by default. Theme is now the only class that knows a complete HTML document. The shell, the head, the 2 sidebars, lifted entirely out of init. Even a value placed inside an attribute, like the contact email in this mail-to link, passes through the very same escape. Escaping at the boundary every single time is the one habit that keeps every later chapter safe. And because the model returns pure data, that same page is still available as JSON, untouched by any of the view work. That is Chapter 4, model for data, view for HTML, theme for the document, and escaping at the edge. Next, Chapter 5 gives every class its own file. Chapter 5 changes nothing you can see, and everything about how the code is organized. Every class now lives in its own file. The front controller shrank to almost nothing. Require Composer's autoloader once, then build the context and run init. That autoloader is configured here, a namespace prefix mapped to a directory. This is the PSR4 standard, and it is the whole point of the chapter. When a request arrives, init builds a class name from that namespace and the requested plugin, and simply creates it. Naming the class is enough. The autoloader turns that name into a file path and loads it, so there is not a single include statement anywhere. The same guard as before protects it. If the name is not a real plugin, the request becomes a clean 404. The abstract base still defines the 5 default actions, each returning a not implemented stub, unchanged, just now in its own file. A concrete plugin is tiny. Home's model overrides list and returns its data, living in its own namespaced folder. Its view sits right beside it, turning that data into the card you see on screen. And theme still builds the navigation with the pipe operator, exactly as it did before the move. The dual output survives the reorganization too. Ask for JSON, and init answers before the theme ever runs. Same data, still available as JSON from a codebase that is now properly filed away. That is Chapter 5, Identical Behavior Professionally Organized, Auto-Loaded by Composer. Next, Chapter 6 adds sessions and flash messages. Chapter 6 adds the first thing a real site needs, state that survives between requests, sessions, and the messages that write on them. The session starts with hardened cookies, HTTP only, same site, strict mode, and secure whenever the connection is encrypted. On the first visit, it mints a single random CSRF token and keeps it for the life of the session. Every form that writes carries that token in a hidden field, rendered of course through the very same escaping helper as everything else. And the server only accepts a write if the submitted token matches, compared in constant time. No valid token, no write. So this contact form is a genuine, protected POST, the real form the server receives, first promised back in Chapter 2. On a valid submission, the model checks the input, queues a message, and redirects the post redirect get pattern that stops a refresh from sending twice. That redirect helper is typed to return never, and it exits, so nothing can run after it. The queued message is a flash, written to the session, then read exactly once on the next page and immediately removed. Each flash carries a level, success, warning, or danger, a backed enum that even maps itself to the right icon. On the next page, theme drains that queue and replays each message as a toast, which looks like this. Submit the form, and after the redirect, your confirmation appears. That is Chapter 6. Sessions, CSRF protected rights, and flash messages. Next, Chapter 7 gives the application a real database. Chapter 7 gives the application a real database. This list of posts is coming straight out of SQLite. The schema is plain SQL, and it loads itself the first time the database file is created, seeded with a few rows to start. The database wrapper extends PDO and sets 3 defaults that matter: throw on error, fetch associative arrays, and use real prepared statements. Its constructor opens the SQLite file, turns on foreign keys, and runs that schema only when the file is brand new. This private method is the one place in the whole app where SQL is prepared and run. Every query funnels through here, each value safely bound. Reads return different shapes depending on what you ask for, chosen by a match expression. And what you ask for is an enum, all rows, one row, or a single column. No magic strings to mistype. So finding one post reads almost like English. Read from posts, where the id matches give me one. Create, update, and delete. Build their statements from array keys, and each is marked no discard, so ignoring the result is a mistake the language itself catches. Writes stay behind the same guard as before. Only a valid, token-checked post reaches the database, and then it redirects. That is this form, a new post, saved with a prepared insert. Even the URL slug is built with the pipe operator. Lowercase it, strip it to word characters, and add a little randomness for uniqueness. Read a single post, and it is fetched by ID with a bound parameter, never glued into the query as text. And the whole list is available as JSON, served straight from the database. That is Chapter 7, SQLite through a tiny, safe PDO wrapper. Next, Chapter 8 adds real users and logins. Chapter 8 adds identity, real users, hashed passwords, logins, and roles. This is the sign-in form. A users table stores each account with a hashed password and a role, seeded with 2 demo accounts to log in as. Logging in looks the user up by email and verifies the password against the stored hash. The plain password is never compared directly. And notice, a wrong email and a wrong password give the exact same message, so an attacker learns nothing about which one was wrong. On success, the session id is regenerated before anything is stored, the standard defense against session fixation. Authorization is a single-ordered enum. Whether one role satisfies another is just a numeric comparison inside a match expression. By default, every method is public. Anonymous visitors are welcome. A plugin tightens that by overriding one method. Here, the entire user's plugin is locked to admins in a single line. This is the choke point every request passes through. Anonymous visitors are sent to log in, and a signed-in but underprivileged user gets an honest 403. So visiting the admin-only users page while logged out lands you straight on the login form. While reading posts stays open to everyone, but the create, edit, and delete controls only appear once an admin is signed in. When an admin creates a user, the password is hashed with the current best algorithm, and on update it is only rehashed when a new password was actually supplied. Even remember me is done properly. A random selector with a separately hashed validator, compared in constant time and rotated on every use. That is Chapter 8, Hashing, Sessions, Roles, and Access Control. Next, the finale, Chapter 9, builds a complete blog and CMS on this foundation. Chapter 9 is the finale, a complete content system, a blog, static pages, and the tutorial's own documentation, all built on the foundation of the last 8 chapters. The trick that keeps it small is a single enum, post or doc. That one value is the only thing that distinguishes the two kinds of content. Because one shared abstract engine does all the work, it opens reading to everyone and restricts writing to admins once for every content type. Its list method filters by type, optionally by tag, and paginates one implementation, serving both the blog and the docs. So the entire blog plugin is this: extend the engine and declare that its type is post. And docs is the same engine again, declaring only that its type is doc. 2 features, almost no extra code. Here are the docs, the very same list engine, showing a different kind of content. A post rendered HTML and its excerpt are property hooks, computed from the stored Markdown the moment they are read, so they can never go stale. And the Markdown renderer is safe by construction. It escapes the input first, before parsing, so no raw HTML can ever slip through. This post was written in Markdown and rendered to safe HTML headings, emphasis, and links, with nothing dangerous allowed. Links are checked against an allow list of schemes using PHP's new URI parser, HTTP, HTTPS, and mail to pass. A JavaScript link is rejected outright. Underneath, one post's table carries the type column, and a pair of tag tables give proper many-to-many tagging. Saving a post rebuilds its tags, deduplicated by slug, so the same tag written 2 different ways never doubles up. And a tag becomes a filter, the same list, narrowed to one subject with a join across those tables. The navigation adapts to who is looking. Everyone sees home, blog, and docs. Admins also get tags and users. And that is the simple PHP Engine, 9 short chapters from a single statement to a complete content system, and never once reaching for a framework. This video was generated, not edited. Each scene is one line of JSON, a narration beat, plus a visual. The voice is Google Cloud Chirp 3 HD, and the clip lengths set all of the timing. The screens are a kiosk Firefox driven by Gecko driver, captured at native 4K with GPU screen recorder. The intro, outro, and titles are HTML and CSS animations, rendered frame by frame in headless Chromium. FFmpeg stitched it together, and the whole pipeline was written with Claude code. It's all in the repo. Thanks for watching.